Hello everyone, welcome to this channel. This question has been taken from Olympiad Pathfinder, Chapter 12, multiple choice question number 22. The question says, small identical balls are attached at each end of a spring of force constant K is equal to 200 Newton per meter and relaxed length L is equal to 20 centimeter. A known amount of charges are gradually transferred to the balls in unequal amounts until the spring length becomes twice of its relaxed length. What amount of work must be done by an external agency in slowly compressing the spring back to its relaxed length? Let us solve this question and see which choice is correct. Small balls are identical. Spring force constant K is equal to 200 Newton per meter. Relaxed length of the spring is small l is equal to 20 centimeter. Unknown amount of charges are transferred on these two balls in unequal amount. Means this charge on this ball is not equal to charge on this ball. What is to find is the work done by an external agency in slowly compressing the spring back to its relaxed length L. Due to the charges on these two balls, the spring length has become 2L. So when you are applying the external force and bring it back slowly to L length, so what is the work done by that force on the system that we are to find out? So let us say final charge on ball as shown in figure 2 be Q1 and Q2. So this is number 1 ball, this is number 2 ball. F12 and F21, F12 and F21 be the electrostatic force on ball 1 due to 2, on ball 1 due to 2 and on ball 2 due to 1 respectively. K subscript P has been denoted for 1 by 4 pi epsilon naught. So now when the system was in this configuration, what was the total energy in this system? Let us say this by E subscript T S I initial. The energy stored, so what will be that? Energy stored in the spring due to stretch and electrostatic energy stored due to charges on ball 1 and 2 because of the interaction between those two charges. So E subscript TSI will be equal to spring has been stretched by L length. So KL square by 2 will be the energy stored in the spring. And due to electrostatic interaction between Q1 and Q2, the energy will be K subscript P into Q1 by Q2 divided by 2L because it is separated by 2L distance. Let us say this equation number 1. We make the free body diagram of ball 2. So this is the electrostatic force acting on 2 due to 1. And KL is the spring force that will act on this ball in this direction. Since this ball is in equilibrium, so from NLM, Newton's law of motion, this force will be equal to this force, means F21 is equal to KL. But from electrostatic, we know that F21 will be K subscript P Q1 into Q2 divided by 2L ka whole square. 2L is the gap between these two charges. Putting this value in equation 2, we will be getting this equation, and finally Kp into Q1 Q2 is equal to 4K L cube, and we will say this equation as number 3. The total energy stored in the system from figure 3, this one, when external force has been applied and it has been brought to this condition, back to the free length of the spring. So this will be equal to energy stored in the spring, but that will be 0 because there is no compression or elongation in the spring, so no energy is stored in the spring. And because of the gap between Q1 and Q2, which is separated by L, the electrostatic energy will be K subscript P into Q1 into Q2 divided by L. So bringing to this configuration, will be equal to work done by the external agency on the system, and that will be equal to the gain in energy in the system, like from final position, energy at final position minus energy at intermediary position, that is 2L length. So the gain in energy in the system will be equal to work done by the external agency on the system W, that is ETSF minus ETSI, and put the value of ETSF and ETSI from the equations what we have obtained. So Kp into Q1 Q2 divided by L minus this. Put the value of Kp into Q1 into Q2 and replace it with 4KLQ. You will be getting this 3KL square by 2. Now finally we can put the value of K. L is 20 centimeter, but we have to take it in meters, so 20 by 100 and a square by 2. You will be getting the answer as 12 joule. 12 joule is given in answer options B, so answer B will be correct. Options B will be correct. Note that the system has been brought to this position or this configuration by the external field applied on it, by the external agency force applied on it slowly. So there is no dynamics or kinetic energy involved in this. That is why we could write this equation. So hopefully you understood the concept of solving it. At any place, any doubt, please write in the comment box. I will look into it and will try to reply. Thank you.